So good morning once again. Today we're going to start our discussion on time series. Okay, this topic is very important because many of the data in finance and economics are reflected as time series data. Now we actually have studied. Uh, excuse me for a while. I'll just close the door. Okay, sorry about that. We have studied panel data regression, although I haven't completed the discussion with that. I'm going to post a video on a more complete discussion of panel data so that you can follow along to compensate for the missed time. Now, there are some references I'm including here. Okay, these are very good references, excellent resources, so that if you're more keen on appreciating time series, I would really encourage you to go through these references. Okay, for example, this one, okay, online stat PSU edu. Okay, this is a good discussion. So let me just open this for your reference. Okay, so stat 510. Okay, so this is from Penn State. Okay, so this subject is all about applied time series. Okay, and then here you can see uh, some theoretical discussion, and it's a good it's a good resource. Okay, although medyo may mga mathematical na ano, pero you go through this class, you read through this, and then you'll learn a lot about the nature and the structure of time series. In fact, we're going to refer to this as we move on. Okay, so let's open our okay. This is another. These are other references uh, which I would encourage you to open and study on. Okay, so these are the packages that we're going to use. Some of this we already know. Okay, so kindly load them if they have not been loaded. Quant mode, I think we have already downloaded. ggplot, of course, we know that. I'm not sure if we have loaded Plotly and ggfortify and TSM. Now, TSM is, did you have difficulty loading TSM? Because it's quite.
Yes, sir.
Okay. If you were not able to load TSM, this is what you do. First, you install remotes, okay, the remotes package. And then after you install remotes package, then you use this function, okay, remotes install GitHub, and then this is the repository Kevin Kotze, and then this is the object TSM, because it's Kevin Kotze who maintains this package. This is a very important package. We're going to use this really very much in this lesson. So I just want to make sure first that you are able to download this and install it. Okay, and then i-library nyo ito pagkatapos ano. Okay, so let me give you some na pala no. Well, afterwards, after you downloaded the package. Okay. So once you're done, once you have downloaded TSM and the rest of the packages, kindly chat below so that I know when to proceed. Let's continue our discussion about our lesson for today, time series analysis. We know the distinction between a cross-sectional data. So we know what a cross-sectional data is, and the distinction between a cross-sectional data and a time series data. So when you look at the data, you should be able to distinguish between the two. You should be able to say with confidence that this is a cross-sectional data or this is a time series data, or the third one being the panel data, okay, which we discussed in the past few sessions. Now, for a time series data, we're looking at just one individual, one unit, okay, and with measures taken across several points in time. Okay, so when we talk about time series analysis, we would like to get insights. Okay, let me see my chat. Okay, mamaya lang Isaac, no? Okay, we're trying to get insights from the time series data by taking a look at the structure and the characteristics and taking a look at patterns for the purpose of forecasting for future events. Okay, there are several methods, several ways of forecasting time series data, and one of the most popular one of the most, let's say, powerful one is the ARIMA model. ARIMA. ARIMA stands for Autoregressive Integrated Moving Average. And at the end of this lesson today, you should be able to understand with confidence what an ARIMA model is. Okay? So ARIMA stands for autoregressive, AR. Okay? When we say AR, we will try to predict the future value of a time series using its past values. So you say here auto, self, autoregressive. Autoregressive means we're using its values itself, the values of the time series itself, to try to predict the future value. So that's why you have it auto, self-regression. Okay. So isn't it that when we have multiple linear regression, we are trying to say predict or to explain a, a a variable using other variables. So we have your dependent variable, okay? We have your response variable being explained by the other explanatory variables. In ARIMA, you're using the variable itself to try to predict itself. That's why it's called autoregressive. And then MA stands for the past error terms. Okay, so that's why you have a combination ARIMA, autoregressive, integrated, moving average. I here, integrated means you have to difference the data first to convert to a stationary time series. I'll explain what stationary is. So these are very important technical terms that we should know. Okay, so let me give an example of what an AR1 process looks like. Okay, so you have here, okay, let me start with AR1. AR1 is Y sub t. You notice it's sub t, okay, to signify that this is a time series. T stands for the time component, time 1, time 2, time 3, time 4. And the time can be in terms of days, can be in terms of weeks, months, years, etc. So depende, no? So we have here a certain constant, A sub O, plus A sub 1 times, okay, take a look at this, Y sub t minus 1. Okay, so we are regressing Y sub t on its past value. Okay, this is an AR1 process. It means, let me just use the annotate here. Okay, AR1 process. An AR1 process, class, an autoregressive process means, okay, you are predicting our time series y sub t based on 1 here stands for log 1. Okay, so let me write this. Y sub t is equal to a certain constant A sub O plus, so difficult to write with the mouse, A sub 1 times Y sub t minus 1. Okay, so your value at times t is equal to is regress on its past log1 value, y sub t minus 1. And then you have an error term here, e sub t. Okay, so this is your AR1 process. So you are predicting the time, the value at time t using the past value time t minus 1. Okay, so that's what we call an autoregressive log1 process. Of course, if it's here in red, you can see here what we call a random walk. What's the difference between an AR1 process and a random walk? The difference is the absence of a sub 1 here. Okay, where a sub 1 here is equal to 1. We will explain what a random walk is as we continue, as we go along. But there's a difference between an AR1 process and this term called a random walk. We will explain this by means of a diagram. Okay, now take a look at AR2. So AR2 is equal to your time series y sub t is equal to a certain constant, a sub o, plus a sub 1 times y sub t minus 1, plus a sub 2 times y sub t minus 2. Notice now that you are including now the log 2, lag, okay? 2 logs now. So in other words, you use the past values of your time series in order to predict the time series itself. Okay? Then an ARP process, in general, you have P lags. So that's y sub t is equal to the constant plus a sub 1 times y sub t minus 1, a sub 2 times y sub t minus 2, a sub 3 multiplied by the log 3 plus etc. a sub, this is a sub p minus 1 second to the last, okay, times y sub t, okay, minus y sub t minus, that should be p minus 1. Okay, sorry about that. And then lastly, a sub p plus times y sub t minus p. So there should be a minus 1 here, sorry. Dapat may minus 1 dito, class, no? And this is a sub p times y sub p plus the error term. Okay, kindly correct this, class. Y sub t minus p minus 1. And it's best if I did not convert this into latex. Maybe as an exercise for you, you can convert this into a latex para kitang-kita yung subscript, no? Kasi dito hindi natin nakikita. Okay. Any questions so far about an AR process? So, ang feature ng AR process, autoregressive of log P, okay, yung P can be 1, 2, 3, depende kung anong log ang gagamitin natin in order to predict our time series. Okay, it uses the past values of itself in order to predict our time series. Okay, we'll illustrate this in greater detail as we move on. Okay, so let me pause for a while. Any questions? Or kindly chat please if clear so far yung discussion natin. Clear so far yung AR process, autoregressive process. So remember, if you're doing an AR process, autoregressive, you're using the past values of the time series itself in order to model our time series. So kindly chat please if the discussion, the explanation is clear so far. Okay, good, thank you. Waiting for the others to give their feedback. Okay, good. Thank you so much for your feedback. All right. On the other hand, what is an MA process? Kasi ARIMA, di ba? ARIMA, yan. ARIMA process. So we know what AR process is. How about MA process? So an MA1 process makes models our time series based on its past error terms. epsilon or e t minus 1. So which means you have this one, e sub t, okay, plus this one, b1, this is our coefficient for the log 1 error term, e sub t minus 1. So that's an MA1 process. So an MA2 process will look like e sub t plus b sub 1 times e sub t minus 1 plus b sub 2, if it's an MA2, b sub 2 times epsilon t minus 2. Okay, you're using the log the log of the past two values of its error terms. Okay, so and you know what an MAQ looks like, no? An MAQ will be y sub t is equal to epsilon sub t plus b1 times e sub t minus 1 plus b2 times e sub t minus 2 plus that until the last. Okay, b sub q, okay, b sub q times e sub t minus q. Okay, so that will be an MAQ process. All right, so let me pause for a while again, and let me again request your feedback if the MA process is clear. So in a nutshell, the MA process makes use of the error terms, past error terms, to model your time series. While an AR process, autoregressive process, makes use of its past values, yung value niya mismo, no? Si AR process. Si MA process, yung error terms niya. Okay? So once again, your chat please if so far clear yung AR at saka MA process natin. In particular, yung MA process. Waiting for your feedback, please. Okay. All right. How about the others? I'm waiting for the feedback of the others kasi aanim pa lang yata ito, no? The fourth, by the way, the activity for the time series will be individual, no? Kasi isa lang to eh. So kayo mismo mag-ano, no? Not a group. Yung panel group siya, pero itong time series, individual to. No? Okay, so let me close this. All right. So if you have a combination, okay, you have an ARMA. Notice ARMA 1-1 process. So the model is y sub t is equal to. So you're now combining the AR process and the MA process. Okay, so this is the AR component here. No? Actually, it includes the error term. This is the AR component, and this is the MA component. There, no? A sub O plus A sub 1 times Y sub t minus 1. This is the AR component. Where we are regressing, we are predicting the time series, okay, based on the past values of itself, Y sub t minus 1. And then include there B sub 1 times epsilon sub t minus 1. So this is what we call an ARMA 1-1. Okay, an ARMA 1-1 process. So therefore, an ARMA PQ, P stands for the log of your Y series, your time series itself, and Q stands for the log values of your error terms. Okay, so it's called ARMA PQ. P for the AR component, Q for the MA component. Okay, so you just put together your ARP and your MAQ. Your ARP is this one, di ba? Ito yung ARP natin. Yung MAQ natin, hindi na natin sinulat dito. But if you combine these two, then you have the ARMA PQ model. Alright. Kapag meron ng ID to, ARIMA, no? Kasi ito ARMA pa lang, ito ARIMA, ARIMA PDQ. No? The D here stands for the difference. Ibig sabihin nito ng ARIMA, you have to difference the data first. What do you mean by difference? What do you mean by difference? Ang ibig sabihin ng difference, you are creating a new time series. So let me just, okay. Oops, wait. Let me first, okay. Let me delete first the, okay. All right. What do I mean by a difference time series? So let me illustrate that here. Okay. ARIMA, no? ARIMA PDQ. It means you're modeling a data which you need to difference first. What do I mean by differencing? Okay, so let's suppose we have this series. Okay, let me just generate 10, 8, 9, 10, 7, 9. Okay, suppose these are the values of your time series. When you say difference time series, you have to get the differencing. Let's say difference 1. It means that you will have to get the another time series. So let's say 8 minus 10, that's negative 2. And then 9 minus 8, that's 1. 10 minus 9, that's 1. 7 minus 10, that's negative 3. 9 minus 7, that's 2, etc. Okay. So it means that you are now modeling this one. This is now what you're modeling and not the original one. Okay. Now there's a reason why you might need to difference the data, which we'll be explaining in a while. Okay. So that's what we mean by difference. So for ARIMA, let's say D is equal to 1, you are actually now modeling a different time series. It's not the original time series, but rather it's now a time series that resulted from differencing by subtracting. So depending on how this data is arranged, it's usually y sub t minus y sub t minus 1. Okay, so what do I mean by that? Maybe this is, let's say, year 2008, and then this is year 2009. This is 2010. So the differencing will be 8 minus 10, 2009 minus 2008, and then 9 minus 8, which is this one. And the time series that will be the result of the differencing will be n minus 1 observations. Why n minus 1? If we had 100 observations for the original time series, the difference time series will only be 99. Of course, because we're subtracting, okay? And we will reduce it by 1 since we don't have the previous value for 10. Okay, pause again for a while. Clear all drawings. Okay, let me once again summarize. When you have ARIMA PDQ, okay, what you're modeling now will be a different time series. It's a time series that has been differenced. Okay, so you're now modeling, as I said, a different time series. So it depends on the log of AR component and the log of your MA component. Okay, so kindly chat please if that was clear, yung AR process, MA process, ARMA process, ARIMA process. Okay, good. The others, please. If you have any questions, please feel free. Don't be ashamed, class, to ask questions. Okay, the others, please. I'm not getting much response from this class, please. Okay, konti na lang nga lang tayo, please. So, ano naman, paki-respond naman. Kung okay ba, kung may question kayo, feel free to ask your questions. Okay, thank you. All right. Now, ito yung mga steps para mag-model tayo ng AR, MA, or ARMA, or ARIMA. No? So very quickly, let's go through this. I won't explain this in detail muna kasi I just want you to be familiar na may mga steps pala when we model a time series. Number one, of course, plot and then check if ito na yung stationary. No? Okay? Pag sinabi nating stationary, okay, constant yung mean. Okay, constant mean. Constant variance. So that's what we mean by stationary. Constant mean and constant variance. Okay, we'll show this when we plot it. Okay, now, if it's not stationary, ibig sabihin, hindi constant yung mean o hindi constant yung variance, you have to do some transformation. Okay, if the data is not stationary, okay, ibig sabihin ng not stationary, hindi constant yung mean, what does not constant in mean look like? Okay, sige, ipakita ko ha. Pag sinabing not stationary, ibig sabihin, may trend siya. Ganito yung data natin. Okay, if you take a look at this, may trend siya, no? It follows a pattern. So, hindi constant yung mean nito. Bakit? If you take a look at this period, ito, siguro ang average niya, ganito, no? Ito yung average niya. Pag dito sa period na to, ito yung data natin, ang average niya, banda dito. Yan. No? So, notice, the averages are not constant over time, kaya not constant yung mean. Okay? So, obviously, kapag yung data natin may pattern, if it behaves this way, ganyan yung data natin, hindi na stationary yan. Okay? And you cannot use the AR process, the ARIMA model, when your data is not stationary. Kailangan, you can only use the ARIMA model, or otherwise known as, by the way, I think I failed to mention that. This ARIMA model was developed by Box and Jenkins ito. No? Right. Box Jenkins approach, which remains to be a very powerful model, although may mga revisions ng konti. Pero this remains to be one of the most powerful model as far as time series is concerned. Okay, so if it's not stationary, then we have to do something about the data. We will have to transform the data. Kailangan may transformation dito. If not stationary, transform the data. Okay, so there are different ways to transform. We're going to look at them, each of them. Number one is to, ito, pag differencing, ang mangyayari niyan, okay, we will now have a new series. Hindi na yung original series yung gagamitin natin, di ba? It will now be a difference data. Or you can do log transformation. So pag hindi siya stationary in mean, ibig sabihin may as I mentioned a while ago, how does non-stationary in mean look like? May trend. Yan. This is not stationary in mean kasi may trend siya. Ano naman tong not stationary in variance? Okay, pag in variance naman, how will that look like? Your data will look like this. Okay, take a look at that. Okay, so sorry for this very crude drawing. Now take note that the mean seems to be constant. Diba? Kung kunin natin yung average nito, at this period, ang average niya ganito eh, no? At this period, ang average pa rin niya, parang ganito pa rin. So although parang nag-i-increase siya over time, but when you get the average, it will still center around this figure. Ito pa rin yung mean niya. No? Okay, approximately this one, this value here. However, tingnan niyo to, no? The spread of the data is not constant. Kasi dito ang spread hanggang dito lang. Pero dito ang spread ng data natin, malaki na. No? So this means that the data is not constant, not stationary in variance. Okay? So dalawa yan ha. Not constant in mean, not constant in variance. Okay, not stationary in mean, not stationary in variance. If you have those two cases, then your data is not stationary. If your data is not stationary, we cannot use the Box-Jenkins approach. Kailangan yung data natin stationary para makapag-proceed tayo sa ARMA or ARMA process. Okay? I hope that's clear, class. Very important muna. Kaya nga kailangan i-plot muna natin. Dapat makita natin stationary ba yung data. Okay? If it's not stationary, then don't bother first. Don't bother modeling it using the Box-Jenkins approach. First things first muna, kailangan maging stationary yung data. Okay, how do we make it stationary? Using some transformation. You might be forced now to use differencing. Okay, so remember, pag differencing ka, you're now modeling a different data set. No? Kasi mina-minus mo na eh, nagma-minus ka na. Okay, pangalawa, okay, second, i-check natin kung stationary siya in variance. How does a stationary invariance look like? Okay, walang fanning out. No? Ito, parang fan. No? Or it can be like this, parang ganyan. May fanning out. No? Ito papasok naman, ito palabas. So when your data behaves this way, okay, non-constant variance yan. So what do we do, class? When the variance is not constant, what do we do? Paki-chat nga, please. What's the word? When the variance is not constant, what do we do? Or the mean is not constant. Class, letter T, ano yun? We transform. Yes, thank you. Thank you, Charles. Yes, we transform the data first. No? So wag kagad tayo gagawa ng ARIMA model kasi hindi mag-work yan. The data has to be stationary in mean and stationary in variance. Both, no? Both. So ito daw sabi, difference log transform data to make stationary on both mean and variance. So kailangan natin gawing stationary. Okay, and then we can check statistically kung stationary na nga using the augmented Dickey-Fuller test, ADF test, or the KPSS test. So there are statistical tests para ma-check natin kung stationary na nga yung data natin. Alright, then 6, 7, and 8, ito na. No? I'll explain what an ACF or a PACF mean. No? Autocorrelation function, partial autocorrelation function. Para ma-identify natin kung AR model ba siya o NA model. Okay, so kailangan para malaman natin kung AR process siya o MA process kasi minomodel na natin. No? Assuming that stationary na yung data natin, we can now proceed with step 6. So actually ito guys yung old way. Ano? We have to plot the ACF and the PACF. Well, hindi naman. It's still necessary. What I meant by the old way was this would take a long time to do. Yung pag-plot. Mahabang proseso yan. Dati nung manual pa lang. Pero ngayon, because of R, ito, sisiw na to. Isang code chunk lang to eh. Okay? Itong 6 and 7, no? Isang code chunk lang yan. Tapos yan. It's so very easy to do now. So time series analysis has become really very easy because of technology like itong R na ginagamit natin. And then we can now forecast and then do diagnostics din. Siyempre, mag-check tayo yung mga residuals ng ARIMA model. Alright? Ngayon, kung yung sa ARIMA model natin, lumalabas na may mga may heteroscedasticity, okay? Ibig sabihin nun, baka hindi sufficient yung ARIMA model. So, anong remedy pag ganun? Kung hindi constant yung variance, malamang ng model natin, yung residuals pala, malamang it will lead us to a further model which we call the Garge model. So ito yung mga didiscuss natin, no? ARIMA at Garge in combination. Garge stands for Generalized Auto-Regressive Conditional Heteroscedasticity. Okay? Garge yun. Kailan tayo mag-garge? Kung nag-residual analysis tayo sa ARIMA model natin and it turns out that the residuals is heteroscedastic. Pag ganun, hindi na kakayanin ng ARIMA, mag-garge na tayo. Okay, let me pause for a while and ask the class, so far clear ba yung steps in order to do an ARIMA model? And then if the ARIMA model is not sufficient, kung anong gagawin natin? Paki-chat please if it's clear so far. Okay. All right. Okay. Let's proceed. Okay. Okay, sabi natin, no? Ito, further explanation lang to, no? Stationary, kasi kailangan natin na intindihan yung stationary time series. Sa physical processes niya, properties like the mean, the variance, are all constant over time. Okay? All right? The series looks like flat. Walang trend siya. Okay? Walang fanning out or fanning in. So yung properties ng time series yan does not depend on time. Okay, let's take a look at this diagram lang, no? Pakita natin tong plot na to. Control C, copy natin to. And then let's all right, take a look at this, no? This is a stationary time series. Yan. Notice, if you get the average across different points, constant yung average, ito siya. Ibig sabihin, wala siyang trend. Kasi pag may trend to, and if you get snapshots of your average, nag-iiba-iba yung average natin. Hindi siya constant over time. This is constant over time, constant mean over time. Also the variance, no? Yung variance natin, wala naman siyang fanning out. Hindi siya parang nag-i-increase over time yung variance. Okay, of course, may mga volatilities, pero constant siya. Constant siya over time. Unlike this one, this is a non-stationary data series. No? This data series, okay, it's not not constant in mean. Okay, may trend siya, no? And it's also not constant in variance. Kasi across different periods of time, okay, you can see that the variance is changing. So this could be non-constant in mean and non-constant in variance. Okay, there's another example here. Tingnan po natin itong isang example na linagay natin dito sa ano natin. Ito magandang example din to. Control C. Para may immediate na ano tayo, class? May immediate na illustration on what a stationary time series or a non-stationary time series is. Okay. All right. Take a look at this. Ito yung kanina, di ba? So this is stationary, this is non-stationary. I think pareho lang yun, no? Okay, pareho lang siya. Ito. All right, this one. Stationary in mean, stationary in variance. This one, okay, if you draw this band, no? And yung variance niya, mukhang hindi naman nagbabago kasi parang same level lang. So this is non-stationary in mean, okay? But stationary in variance siya. Ibig sabihin yung volatility natin, it, it, it still looks constant over time. Pero yung mean niya nagbabago. If we take a look at different segments, yung average ng data na to, it's changing over time. Then this one, again, this is what I illustrated a while ago. This is stationary in mean. Wala namang siyang trend, no? Okay? But not stationary in variance. Yung plot natin to, kita nyo, guys, over time, parang lumiliit yung variance. Okay, so this is to illustrate what stationary in mean and stationary in variance mean. Okay, balik na tayo sa ano natin, model natin. All right. Okay, then, okay, there's this term called white noise. Huh? Okay, white noise. We will explain white noise more later on, no? Pero it just says that white noise is stationary, which means walang trend, walang seasonality, no? Okay, and then constant yung variance over time. All right. Okay, so let's a stationarized series is relatively easy to predict. Okay, that's why yung Box-Jenkins approach makes sure that the data is first stationary bago magpa-plot, bago i-model ng ARIMA. No? Okay. Predictions for the stationarized series can then be untransformed. What do we mean by this? So, kunyari yung data muna natin, hindi siya stationary. Okay, tapos, anong mangyari? Ita-transform muna natin data para maging stationary. So, pag naging stationary na siya, tapos i-model na natin, nakuha na natin yung model, we can untransform. Okay? We can untransform para bumalik sa original data. Para yung prediction natin, we can still predict, no? Using the model. Okay, we'll have an example of this where we transform the data, tapos i-model natin, and then magpe-predict tayo. Pero ang prediction natin kasi, di ba kung bago na yung data natin, kunyari, dinifference natin siya, hindi na yun yung dating, yung original na data. Okay, if we want to predict the original data, i-untransform natin yung yung model natin. Okay? All right. So let's have this example. Okay, we're going to use the data air passengers, and this is from air passengers. Ang ano ba to? Ang galing na base R ba to? So this is a data set coming from maybe it's base R na yata siya. Let's just check kung saan nanggaling tong air passengers na data set na to. Tagal ah. Okay? Ito. From the data sets package. Ito class, no? Data sets. Okay, so there's this package called data sets that come loaded with R. Okay, so this is the classic Box and Jenkins. Take a look at this, guys. So ito yung example, nung minodel ni Box and Jenkins, sila ng, they proposed the ARIMA model. This is one of the data that they use, air passengers. So this is air passengers, 1949 to 1960. It's a monthly time series in thousands. Okay. So lagay natin dito para alam nyo kung saan galing to. Let's put here data sets. Okay, let's see. Okay. Kasi ginamit ko yung data. No? Okay. Mali itong ano The air passengers data set come from the datasets package. Pero ito kasi yung function natin data. Yung data na to galing sa base R yan. Hindi naman siya galing sa datasets ng package. So I can't use datasets before data. No? Okay, let's run this. So let's check. Let's view air passengers. All right. So ito na yung data natin, no? I notice na kahit nag-view ako, no? Hindi siya nag-run, no? Okay. Did it generate a... Is it because it's a time series? Did it generate a spreadsheet of the values for you, class? Paki-chat naman, please. Nung nag-view kayo, nag-generate ba siya ng ano? No. Okay, how about the others? Itong view na to, did it generate a list of the time series sa inyong class? Paki-chat, please. Hello, guys. Come on, guys. Come on. Answer, please. Okay, no. Okay. Yeah. It would be good for us to check, no? Bakit kaya hindi siya nagge-generate ng ano? Hindi ko alam no? Kasi before, ganito code, matagal ko na ginagamit tong code na to itong air passengers na to. When I view it, lumalabas yung ano, yung print out niya, no? Tingnan ko nga kung ano naman to. Yung class niya, alam ko data frame din to Time series siya, no? So it's a time series. Is it because it's a time series kaya hindi siya nag-generate ng view mismo? Okay, I'll have to discover that. Help me also research on that class, bakit hindi siya nag-generate ng ano. Is it because it's a time series? So that remains to be seen. Hanapin natin kung ano. Okay, so let's ang haba ng air passengers na name, let's just replace it with AP. Okay? And again, mangyayari nito, ganun din, no, si AP. Hindi rin niya ipiprint. Okay, so let's analyze AP. Take a look at head. Head na lang. Head ni AP. Okay, so ito yung structure ng data niya, no? Okay, siguro let me print the full one. Okay, so this is AP. So these are the months, November, January to December, and then year 1949 to 1960. So 12 years to. Okay, and then these are in thousands. These are the air passengers. These are air passengers in thousands. Okay, so this is a time series. time series data set siya. You only have one unit, one individual, and that's the air passengers taken across several points in time. So 12 months, 12 years, so this is 144 observations. Okay, let's check if there are missing values. Let's get the sum. Pero obvious naman na wala. Sum of lahat ng mga is NA. Frequency nito, let's see the frequency kasi time series siya, 12. Ibig sabihin monthly data to. Cycle. Okay, great. Cycle. Yan, tingnan nyo guys yung cycle, no? 1949, 1 up to 12. 1951 up to 12. Okay, so we can see here the monthly data for 12 years, from 1949 to 1960. Okay, and then summary. Okay, we have the mean, the median. Okay. All right. Any questions so far, class? Clear so far yung ano natin, clear so far yung data natin. Time series siya. Okay. It's a time series. And then data is taken from 1949 to 1960, monthly data from January up to December. Okay, so let's continue. Let's plot the data. Okay, so here we use the base R function plot. We're plotting AP. Let's put a label to the x-axis and y label to the y-axis. Okay, date. Y label is passenger numbers, passenger number in thousands. And then main title of the plot is air passenger numbers from 1949 up to 1960. And then we plot using the plot function. See, let's plot. Okay, so we can see here our air passengers data set. Okay. All right, so let's categorize this. Is this stationary data? Kindly chat, please. Is this stationary? Is our air passengers data set stationary? Is it constant in mean and constant in variance? Okay, how about the others? Sophia, kindly share your answer to everyone, please. Okay, how about the others? Ano answer nyo? Stationary ba to? Is our data stationary? Constant ba siya in mean? Okay, if you take a look, if you chop the data in different time frames, yung mean ba niya pareho? Is the data constant in variance? I'm waiting for your response, guys. Let's hopefully let's answer please. Sana mas immediate para we can cover more materials kasi sometimes naghihintayan tayo. Okay, thank you. You're correct. This is not a stationary data. Kasi unang-una, non-constant in mean siya. Okay, when we say non-constant in mean, sabi natin, diba? If you take a look at the try to get the average across several periods of time, the average is increasing. May trend siya, no? Okay, that will tell us kung constant yung mean siya. Constant yung mean niya. Hindi. Kasi may may trend. Secondly, constant in variance ba? Again, tinan niyo yung dispersion ng yung variation niya, diba? Here, yung variance dito, maliit lang. Pero across time, ano nangyayari? Lumalaki yung variation. In other words, Okay, di ba? Take a look at this. May fanning out siya, no? The variance is increasing over time. Okay, so non-constant mean, non-constant variance. Okay? So even if non-constant mean lang siya, tapos yung variance is constant, still hindi pa rin siya, not stationary pa rin siya. So this is not stationary. This series is not stationary because the mean is not constant and pareho dapat, no? The variance is not constant over time. They have to be both constant, both mean and variance have to be constant in order for the time series to be stationary. Okay. Clear ko ulit. Okay, ano nangyari dito sa natin? All right. So, there's another way to plot this using GG45. Okay, so here we have autoplot AP plus the labels P2. Let's plot this. Okay, so this is another way to plot it using ggplot. Okay, ito yung function. All right. Now, we can also plot kasi you notice, hindi ko pala nabanggit, ano, may trend siya, may seasonality ba siya? Plot ko itong autoplot natin. Is there a seasonality? Does our time series have seasonality? Ano ibig sabihin ng seasonality? May mga times yung constant yung na nag-i-increase at saka nagdi-decrease. If you take a look at the pattern, 'di ba dito aakyat dito sa baba. Tapos here aakyat naman, baba. Akyat, baba. So you can see here an observed seasonality. So may mga months na tumataas siya. Ano ba to? December ba to? Or so let's investigate this. Tapos may mga months naman na bumababa siya. So there seems to be a cyclical pattern, and that's called seasonality. Okay, so may trend siya, may seasonality pa, at saka non-constant yung variance, making this an non-stationary data series. And remember, pag hindi stationary yung data series natin, we cannot use the ARIMA model. All right, so let's make use of the box plot. So si AP, ipa-cycle natin. Okay? So it will generate the box plot. Tapos by yung cycle, which is the months. So let's take a look at this. All right. Okay, here you can see. Okay, it seems that so collection to ng January 1949 to 1960. February 1949 up to 1960. So ito December 1949 up to 1960. So pinagsama-sama niya yung details ng January, February hanggang December, and you notice that July seems to have the biggest number of air passengers. July, and then we have August, no? Sila yung pinakamataas na median. Ito yung box plot natin. Tapos sila din yung pinakamataas sa mga air passengers. Okay? And then yung pinakamababa seems to be February or November, no? Ito yung bumababa yung yung plot natin. Looks like February, no? Bumababa siya. Tapos even sa November may ang median niya pagbaba, no? So most probably this is yung uptick natin, yung pagtaas, it's siya din pinaka-highest point, no? Yung maximum. So si July, ang very busy yung or mataas yung air passengers. Okay? So from these explanatory plots, no, may mga inferences tayo. Okay, let's take a look quickly at this. Number one, air passengers increase over time with each year. Okay, so ibig sabihin nito, may trend siya. No? Okay, second, dun sa box plot, ano nakita natin? Yung pinakamataas, yung from June, July, August, September, no? From month 6 to 9. Higher means and higher variances siya. So this indicate that there is seasonality dun sa months na yun. Okay, so ang context yan, ano kaya, no? Bakit kaya tumataas sa June, July, August? We don't know, maybe summer months kasi sa US yun. Okay? All right, then also air passengers appear to be multiplicative time series. Okay? As the passenger numbers increase, it appears so does the pattern of seasonality. So pag sinabing dalawang klase kasing no? Time series, yung multiplicative at saka yung additive. Okay, itong natin, itong time series natin, okay, it's multiplicative. Bakit siya multiplicative? Kasi, okay, let me illustrate that again. Kailangan pa natin itong plot na to. Why is it multiplicative? Okay, it's multiplicative because of the fanning out. So multiplicative to. Pag additive naman, class, constant lang. Hindi nag-i-increase yung variation natin. Unlike this one, talagang yung natin yung variation natin tumataas eh. So this is a multiplicative time series. Kung constant lang siya na ganito lang, just like the illustration that I gave a while ago. Okay, so let me just show that. May gamit pa to. Ito, no? Okay, this is multiplicative. This is additive. Multiplicative time series, additive time series. Okay. Going back. To our observations. Bilis ng oras. Okay. So, ito na lang guys, no? Kindly take a look at this. We don't have time to look at that. So, yung difference ng additive at saka multiplicative na seasonality. Ito, i-run muna natin to. I-decompose natin. So, from the stats package, merong function na decompose. And then you can decompose the time series. You can either choose additive or multiplicative. And then plot natin. So, run natin to. Okay. Tingnan natin, no? So here, makikita natin decomposition ng data natin. Yung first, yung first figure dito, this is the original data. Now take note, it is broken down into 3. Okay, ito yung random, ito yung seasonal, ito yung trend. So first, tinanan yung trend, yung linear trend. Second, yung seasonality. So kitang-kita natin that there are really points na tumataas siyang ganun. So this is yung June, baka ito yung July, no? Yeah, June, July to, no? Magkasunod siya. Or June, July, August. July, August, pwede. July, August. and this is the trend, and this is what? This is the remainder. No? Ito yung ito yung parang ano na, yung parang hindi na makakuha dun sa seasonality at saka dun sa trend. Ito na yung natitira, no? Sa data natin. Okay, so this is what the decomposition function looks like. Okay, so that's a very good function. All right. Abot tayo ng ano ng dito, no? Sa test ng stationarity. Okay, kung ano ba siya, kung statistically we will test kung stationary siya. Okay, so let's use the ADF. This is the augmented Dickey-Fuller test. Sulat nyo, class? Augmented Dickey-Fuller test. Okay, so that's the augmented Dickey-Fuller test. Then we want to statistically test kasi binisualize lang natin. Pero obvious naman na hindi stationary. No? Pero mas maganda kung may test pa rin siya. No? All right. So the alternative hypothesis here is that the series is stationary. Of course, the null hypothesis is the series is non-stationary. Okay, and the p-value is 0.7. This is less than or greater than 0.05. So we fail to reject the null hypothesis that the series is not stationary. Okay. All right. As one of your very quick assignment, KPSS. Also use the KPSS test research yan. Okay. KPSS test. Test for stationary. So please include there the code. Compare notes next meeting. Okay. All right. It's almost time. So next meeting, i-discuss natin tong yung autocorrelation and partial autocorrelation. Ito na, no? This is already step. Let's review our steps, diba? So what we have done was to plot the data. Okay? Actually, hindi pa tayo nagmo-model, Hindi pa naman tayo nagmo-model. Alam natin na not stationary siya. So the next step should be to transform your data. No? Hindi pa natin ginagawa yun. Pero i-check lang natin si ACF. Okay, just to show you that the data is indeed not stationary. So we're using this in order to show if the data is not stationary, or not. So let me plot the first one. Okay, so this is the autocorrelation function. Okay, and also the other one is the partial autocorrelation function. Okay, so the ACF ito and the PACF. So next meeting i-discuss natin ano ba yung itsura dapat ng isang stationary data. Pag prinat natin yung ACF niya, ano dapat yung itsura? Okay? Ano dapat yung itsura niya? How does it look like if we plot the PACF? Alright, so next meeting, that's what we're going to discuss. And also this one will tell us kung ano yung possible na model dito. Ano ba to? ARIMA ba? Or MA or ARMA model? Okay, so ito, same plot as above. Just plot this. Yan. Just use the ACF. Okay, but the one that I like really, the dalawa, no? The one that I like is from the TSM package, and I'll end in this. Okay, so make sure, di ba, na-load na natin si TSM. Okay, and then using the AC plot of TSM. So for me, this is the best, no? This is the best plot. Okay. Ba't mag-DL dito? Okay, tanggalin nyo nga muna to, class. At may DL tayo dyan. Okay. TSM package AC function. Yan. Okay. So that's why I like the TSM package kasi dito, yung plot natin ng ACF, autocorrelation function, and your partial autocorrelation function, combined na siya, pinakita na kagad sa atin. So next meeting, we're going to discuss, what does this tell us? Is our data stationary? We already have shown using the augmented leaky cooler test that our data is not stationary. This one also will tell us that hindi stationary yung data natin. Itong slow decay na to, yan, sa ACF, okay, it means that our data is not stationary. Okay, and also this one, it's a partial autocorrelation function. Okay, all right, so let me pause there. Let me stop recording.